What if everything you see, every star, every atom, even your own existence, wasn't random at all? What if the universe was set up with precision so exact it almost feels intentional? This isn't science fiction. It's one of the deepest and most serious questions scientists and philosophers have ever faced, and today we're stepping right into the center of it. For thousands of years, thinkers have asked whether the universe was designed. But in the age of modern physics, that question has taken on a whole new level of urgency. Is there something built into the very structure of reality that suggests intention? Could the laws of physics have been chosen rather than randomly formed? Were the fundamental constants carefully set to allow complexity, structure, life, and eventually consciousness? Or is everything simply the way it is, with no deeper reason at all? This question sits at a fascinating intersection where physics meets philosophy, where science meets meaning. And while physics alone cannot give a final answer, it has revealed something remarkable. The universe behaves in ways that make this question impossible to ignore. The goal here isn't to give you a final conclusion, because there likely isn't one yet, but to walk you through what modern physics has uncovered, to present both sides fairly, and to show why intelligent people can look at the same evidence and reach completely different conclusions. Let's begin with something concrete, something discovered through decades of observation and mathematical analysis, a phenomenon that has convinced many physicists that the universe looks designed even if they hesitate to say it actually is. This phenomenon is known as fine-tuning. Fine-tuning refers to a striking fact. The fundamental constants of nature, the numbers that appear in the equations of physics, seem to be set with extraordinary precision. These values fall within incredibly narrow ranges that allow the universe to support structure, complexity, and life. Change even one of them slightly, and the universe would be completely different. In some cases, stars wouldn't form. In others, atoms would become unstable. Chemistry could fail entirely. Matter might collapse too quickly after the Big Bang, or spread out so rapidly that nothing could ever come together. The universe we observe exists within a tiny window where everything just works. And that narrow range raises a powerful question. Is this coincidence or something more? To understand how precise this is, we need to look at specific examples, because the details matter. Start with the strong nuclear force, the force that binds protons and neutrons inside atomic nuclei. This force is about 100 times stronger than electromagnetism, and that ratio is crucial. If the strong force were slightly weaker, a key particle called deuterium would not be stable. Without it, stars couldn't fuse heavier elements. No carbon, no oxygen, no nitrogen, just hydrogen forever. Chemistry as we know it would not exist. But if the strong force were slightly stronger, the opposite problem appears. In the early universe, almost all hydrogen would have fused into heavier elements immediately. That means no hydrogen left for water, no organic chemistry, and no life based on the systems we depend on. So this force must sit within a very narrow range, not too weak, not too strong. Now consider gravity. Compared to other forces, it's incredibly weak, about 10 to the power of 39 times weaker than electromagnetism. No one fully understands why. But we do know that if gravity were much stronger, stars would burn out far too quickly, lasting millions instead of billions of years. There wouldn't be enough time for planets to form or life to evolve. If gravity were weaker, matter wouldn't clump together at all. No galaxies, no stars, just a thin cloud of particles drifting endlessly. And this is just the beginning, because as we move deeper into these constants, the pattern becomes even more precise and even more difficult to ignore. And the deeper we go, the more unsettling this precision becomes. Because it's not just one or two constants that appear finely balanced, it's many of them, all at once, all working together in a way that allows the universe to exist as we know it. Take the cosmological constant, often associated with what we call dark energy. This is the mysterious force driving the accelerated expansion of the universe. Its value is unbelievably small, so small that physicists often describe it as one of the most puzzling numbers in all of science. If this constant were even slightly larger, by a factor of just 10 or 100, the universe would expand too quickly. Matter would never gather into galaxies, stars, or planets. Everything would drift apart before structure could form. On the other hand, if this value were negative or significantly different, the universe might have collapsed back in on itself long before anything complex had a chance to develop. Yet somehow, it sits precisely in the narrow range that allows cosmic structure to emerge. And the list doesn't stop there. The ratio between the mass of the electron and the proton plays a crucial role in atomic stability. The small difference in mass between neutrons and protons determines how nuclei behave and how stars fuse elements. The strength of the electromagnetic force affects whether atoms can form stable bonds at all. Even the properties of the Higgs field influence the masses of fundamental particles and therefore the entire structure of matter. Again and again, we see the same pattern. These values fall within narrow limits that allow complexity. When physicists first began to fully grasp this in the mid-20th century, it was deeply surprising. It seemed almost impossible that so many independent parameters could all land within such precise ranges purely by chance. To put it into perspective, it's like throwing a dart at a target the size of a galaxy and hitting a bullseye the size of a single atom. The odds feel absurdly small. And naturally, this led many to consider a bold possibility. Maybe the universe was designed. But before jumping to that conclusion, we need to slow down and examine the assumptions behind it. Because the idea of fine-tuning depends on something we're not entirely sure about, that these constants could have been different in the first place. What if they couldn't? What if there is a deeper, still unknown physical law that fixes these values exactly as they are? If that's the case, then there is no tuning happening at all. The universe wouldn't be finely adjusted, it would simply be the only possible version of itself. There's another issue as well, probability. When we say something is unlikely, we're assuming a way to measure that likelihood. But in the case of the universe, we don't actually know what the correct probability distribution is for these constants. What counts as a random universe? What values should we expect? Without a clear answer, claims about improbability can become uncertain or even arbitrary. And then there's something known as the selection effect, often referred to as the anthropic principle. Even if life-permitting universes are extremely rare, we would only ever find ourselves in one that allows life. We couldn't exist in any other kind of universe. So the fact that we observe conditions suitable for life might not be surprising at all, it could simply be unavoidable. But here's where things take an interesting turn. There are two ways to interpret this idea. The weaker version just states the obvious. Of course the universe supports life, because otherwise we wouldn't be here to notice it. That doesn't really explain anything, it just describes the situation. The stronger version, however, suggests something much bigger. If there are many universes, perhaps an enormous number, each with different physical constants, then it's not surprising that at least one of them would allow life. We would simply be in that rare universe, because it's the only kind we could observe. This idea leads directly to one of the most debated concepts in modern physics, the multiverse. Instead of a single universe, there could be countless universes, each with different properties. In that scenario, fine-tuning doesn't require design, it becomes a matter of selection among many possibilities. And just like that, we arrive at the heart of the debate. Two major explanations stand in front of us, design or multiverse. And the real question becomes, which one actually makes more sense? Let's start with the argument in favor of design, because on the surface, it feels intuitive. The reasoning goes like this. The fine-tuning we observe is real, and it demands an explanation. The constants of nature sit within extremely narrow ranges that allow life and complexity to exist. That doesn't look accidental, it looks intentional. From this perspective, there are two main possibilities. Either there is only one universe, and it was deliberately arranged to support life, or there are many universes, and we just happen to be in one of the rare ones where life is possible. Supporters of design often argue that the multiverse option is excessive. It proposes an enormous, possibly infinite number of unseen universes, just to explain the one we can observe. That can feel like an unnecessary complication. In contrast, design introduces a single cause, a creator or intelligent agent responsible for setting the conditions. There's also a deeper concern. Even if a multiverse exists, it doesn't truly eliminate the problem, it just moves it. You still have to explain the mechanism that produces all these universes. Why does that mechanism generate a range of constants that includes life-permitting ones? Why not only sterile universes? Another criticism is that the multiverse may be fundamentally untestable. If other universes are completely disconnected from ours, we may never be able to observe or measure them. That leads some to argue that the multiverse is not really physics, but philosophy disguised as science. And then there's everyday intuition. When we encounter something that appears carefully arranged, we usually infer design. If you walked along a beach and found stones forming a clear message, you wouldn't assume the waves randomly placed them. You would conclude that someone arranged them intentionally. In the same way, many people look at the universe with its precise constants and structured laws and see the signature of intelligence behind it. But now let's turn to the other side, because the argument against design is just as serious and just as compelling to many thinkers. The first response is straightforward. Saying, a designer did it doesn't actually explain the phenomenon. It simply labels it. It doesn't tell us how the constants were chosen, why those specific values were selected, or where the designer itself comes from. In fact, it may introduce an even bigger mystery. If we ask why the universe exists in this particular way and answer, because of a designer, we can immediately ask, Why does the designer exist? Why does it have those properties? Why does it choose to create universes at all? Some argue that the designer could be a necessary being, something that must exist by its nature. But if that's allowed, then why not say the same about the universe itself? Why assume the universe needs an explanation beyond its own existence? There's also the question of simplicity. At first glance, a single designer might seem simpler than an infinite multiverse. But simplicity isn't just about counting how many things exist, it's about how complex those things are. A conscious, intentional mind capable of designing universes might be far more complex than a system of physical laws generating many universes. And importantly, the idea of a multiverse didn't appear just to solve fine-tuning. It arises naturally in certain physical theories, like eternal inflation or some interpretations of string theory. In that sense, it's not an ad hoc explanation, it's a possible consequence of deeper physics. There's also a powerful historical lesson. Appearances can be misleading. Snowflakes look intricately designed, but they form through natural processes. Living organisms seem purposefully built, yet evolution explains their complexity without requiring a designer. Even the structure of the solar system emerges from gravitational dynamics. So the appearance of design does not guarantee actual design. And as we continue, the question becomes even more subtle because the deeper we look, the less straightforward the answer seems. And as we move deeper into this discussion, one of the most striking examples of fine-tuning brings everything into sharper focus. It's not abstract. It's not theoretical. It's something directly tied to your existence because it explains how the very atoms in your body came to be. This is the case of carbon. Nearly all the carbon in the universe, the element that forms the backbone of life, was created inside stars. But for carbon to form efficiently, something extremely specific has to happen. The carbon nucleus must have a very precise energy level known as a resonance state. Without this exact value, the process that builds carbon inside stars would barely work at all. In the 1950s, astrophysicist Fred Hoyle made a bold prediction. He reasoned that since we exist and are made of carbon, stars must be capable of producing it. That meant this specific resonance had to exist even though it hadn't been observed yet. And when scientists looked for it, they found it almost exactly where he predicted. It was a remarkable success of reasoning based on what we now call the anthropic principle, the idea that the universe must allow observers like us to exist and therefore must contain the conditions necessary for our existence. But what makes this even more fascinating is that this carbon resonance depends on the fundamental constants of physics. Change those constants slightly, and carbon production becomes inefficient. Without abundant carbon, life as we know it becomes extremely unlikely. Now, some might argue that we're being too focused on carbon-based life. Maybe other forms of life could exist based on different chemistry. That's possible. But carbon has unique properties. It can form long, stable chains and complex three-dimensional structures. Alternatives like silicon are often suggested, but their chemistry is far more limited. Carbon stands out in a way that's difficult to replace. From here, the conversation expands beyond fine-tuning into something even more puzzling, the mathematical nature of reality itself. Why is the universe describable with such precise equations? Why do mathematical concepts sometimes develop with no connection to the physical world end up describing it so accurately? Physicist Eugene Wigner famously called this the unreasonable effectiveness of mathematics. And the mystery goes even further. Not only is the universe understandable, it's understandable by us. Think about that for a moment. A species that evolved on a small planet, shaped by survival in a natural environment, somehow developed the ability to understand relativity and quantum mechanics. Why should the human mind be capable of grasping the deep structure of the cosmos? For some, this suggests a deep harmony between mind and reality, as if both come from a shared rational source. Others take a more naturalistic view. Mathematics may simply be the language of patterns, and any universe with consistent patterns can be described mathematically. Our cognitive abilities, in turn, may have evolved from simpler survival skills and gradually expanded into abstract reasoning. There's also the question of beauty. Many physicists describe the fundamental laws of nature as elegant, symmetrical, even beautiful. These qualities have sometimes guided the development of new theories. But why should the universe be beautiful at all? A supporter of design might say that beauty reflects intention, that a creator valued elegance. A naturalist might respond that what we call beauty is simply our recognition of deep symmetry and efficiency, and that we've learned to associate those features with successful theories. Then there's consciousness, perhaps the most mysterious aspect of all. We still don't fully understand how physical processes in the brain produce subjective experience. We can study neural activity, but that doesn't explain why experiences feel the way they do, or why they exist at all. This is often called the hard problem of consciousness. Some see this as evidence that consciousness might be fundamental, not reducible to matter alone. That idea could open the door to views where mind plays a deeper role in reality itself. Others believe that even if we don't yet understand it, consciousness will eventually be explained through physical processes. But here's the key point. This issue doesn't map neatly onto the design debate. You can believe in a designer and still think consciousness arises from physical systems. Or you can reject design and still think consciousness is fundamental. The connection is not as simple as it might seem. And just when it feels like we've reached the limits of complexity, another layer appears, because it's not only the constants that seem finely balanced, but the very beginning of the universe itself. Because beyond the constants, there's something equally remarkable: the initial conditions of the universe. The way everything started also appears to be incredibly special, and possibly just as finely tuned. The early universe had to be extremely uniform, with only tiny fluctuations in density. These small variations were essential. Without them, matter wouldn't have clumped together to form galaxies and stars. But if those fluctuations had been much larger, the universe could have collapsed into chaos. It also had to begin with a density incredibly close to a critical value. Too much density, and the universe would collapse quickly. Too little, and it would expand too fast for structure to form. Somehow, it started in a narrow range that allowed complexity to emerge over billions of years. Perhaps most puzzling of all, the universe began in a state of extremely low entropy. According to the second law of thermodynamics, entropy or disorder tends to increase over time. That means the universe started in a highly ordered state, which is statistically very unlikely. Physicist Roger Penrose has emphasized just how extraordinary this is. The probability of such an initial state is so small that it challenges our understanding of why the universe began the way it did. There are attempts to explain this, such as cosmic inflation, a theory suggesting that the universe underwent a rapid expansion early in its history. Inflation can smooth out irregularities and help explain the large-scale structure we observe today. But even inflation doesn't fully solve the problem. It requires its own specific conditions and parameters. In other words, it may shift the fine-tuning issue to another level rather than eliminate it entirely. And this pattern keeps repeating. Each time we find a potential explanation, new questions emerge. The mystery doesn't disappear, it evolves. Now suppose for a moment that fine-tuning really does point toward design. Even then we face a difficult question. What kind of designer are we talking about? The evidence alone wouldn't tell us. It wouldn't confirm any specific religion or tradition. The designer could be a single intelligence, multiple agents, an impersonal force, or something entirely beyond our current understanding. And immediately, another question arises, one that's impossible to ignore. If everything requires an explanation, then what explains the designer? If the answer is that the designer exists necessarily, then someone could argue that the universe itself might also exist necessarily. Then there's one of the strongest objections to a traditional, all-powerful, benevolent designer: the problem of suffering. If the universe was created by a being that is both all-powerful and perfectly good, why does it contain so much pain, violence, disease, and destruction? Philosophers have tried to answer this in many ways. Some argue that suffering is necessary for free will, or for moral growth, or for achieving a greater good beyond our understanding. But for many people, these explanations are not fully convincing. The mixture of beauty and cruelty in the universe raises serious doubts about the idea of a perfectly benevolent designer. At this point, the question itself begins to shift. Maybe it's not just about whether the universe was designed. Maybe it's about whether the universe has purpose, direction, or an inherent tendency toward complexity and consciousness. It's possible that reality is structured in a way that naturally leads to these outcomes, not because they were chosen by an external mind, but because they arise from the deep nature of the universe itself. This idea suggests a kind of built-in direction without requiring a personal designer. And that opens up a middle path somewhere between intentional design and pure randomness. A possibility where the universe is not guided from the outside, but still not entirely accidental either. But no matter which perspective you lean toward, one final question remains, and it may be the most important of all. Because beyond physics, beyond theory, beyond explanation, this question reaches directly into how we understand our own existence. In the end, this isn't just a scientific question, it's a personal one. What you believe about the universe shapes how you see your own existence, your purpose, and your place in reality. If the universe was designed, then your existence may not be accidental. It could mean there is intention behind reality itself, that life and consciousness were meant to emerge. This idea suggests a deeper sense of purpose and belonging, possibly even a moral structure built into the universe. But it also raises difficult questions. Why does suffering exist? Why would a designed universe include pain, chaos, and destruction? And it requires accepting a designer beyond the natural world. If, instead, the universe arose naturally without intention, then our existence is not predetermined. There is no built-in purpose, but that doesn't make life meaningless. It means meaning is something we create. That can feel uncertain, but also freeing. It gives us responsibility to define what matters, to build relationships, and to decide how we live. Life may be temporary, but that can make it more valuable, not less. So what can we conclude? The universe does show signs of fine-tuning. The constants of nature fall within narrow ranges that allow complexity and life, but explaining why remains difficult. There are three main possibilities: design, multiverse, or deeper physical laws we don't yet understand. Each has strengths and challenges. None is proven. That's why this debate is still open. Physics can define the problem clearly, but it cannot fully solve it yet. Reasonable people can look at the same evidence and reach different conclusions, and that's part of the process. What matters most is intellectual honesty, recognizing what we know and what we don't. Because even without final answers, asking these questions has value. It helps us understand not just the universe, but ourselves.